I'm Alexandra Tudoroiu Lakavičė. Good afternoon. I will be presenting on behalf of COGEN Europe, the coordinator of the PACE project. So just a few details about the PACE project. This is a EU co-funded project via the Fuel Cells and Hydrogen Joint Undertaking. It's a large-scale field trial project which aims to deploy more than 2,800 fuel cell micro-CHP systems across Europe by 2021. It has an overall budget of 90 million euro, out of which around 30 million is co-funded by the European Commission via the Fuel Cells and Hydrogen Joint Undertaking, and the rest is funded via the industry partners in this project. COGEN Europe acts as the coordinator of the project. We are actually gathering the key manufacturers for fuel cell micro-CHP products. You can see them on these slides. These are the main manufacturers for heating systems in Europe that are now bringing into the market fuel cell micro-CHP systems as well. So the manufacturers involved in the project include Solid Power, Bosch, Sunfire, Wiesmann, BDR Thermea. You will find most of them in the premises of Hannover Messe, so you can, after this talk, go and talk to them. And we also have research partners involved, Element Energy, DTU, so the Danish Technical University as well. So as I mentioned, the aim of the project is to deploy more than 2,800 units. However, we're also aiming at developing the markets for this product across Europe. So we have 4 target countries, Belgium, the Netherlands, UK, and Italy. While the field trial will be taking place across Europe, the core countries to develop the markets will be these 4 I mentioned. So a bit about the basics of fuel cell micro-CHP. We are in the Hydrogen and Fuel Cells joint exhibit. So here the big topic is hydrogen, but we're also representing the fuel cells sector, and more specifically stationary fuel cells. So these are very small systems that are installed in households and SMEs, so in commercial premises as well. They have a connection to the gas grids, they use gas, they reform it, transform it into hydrogen, and then hydrogen is used to produce jointly heat and electricity in a very efficient way. As you can see, they reach very high efficiencies, total efficiencies of 95%. The SOFC units will reach electrical efficiencies of up to 60%, while the PEM units will have efficiencies of 35%, which are very high efficiencies for on-site systems. So where do fuel cells fit into the future energy system? We know that they're very efficient today, but how will they fare in this very big field of unknown, really, because we're looking at 2050. We're looking to have a carbon neutral energy system by then. And there's many different pathways to reach that objective. So those pathways involve energy efficiency, renewable energy, decentralized energy. We also talk a lot about sector integration, integrated energy systems. Electrification is coming up a lot in policy and also industry debates on this topic. And we also want energy to be affordable and reliable. So in that context, we're looking at the challenges that we will have in the future when it comes to energy, and how fuel cells will actually deliver on some of those challenges. So looking at renewable energy, we could be thinking of a 100% renewable energy system, However, we know that renewable electricity can be intermittent. We know that renewable energy heat, there's an issue with the availability of biomass, for instance, geothermal, solar thermal. That can also be a challenge. And sustainability of some of these fuels is also under debate. So actually with renewable energy, we have the challenges of how we will be deploying all those massive amounts of renewables that we do need for the energy system, and also what will be the costs of those. Then we have electrification, and we know that for the building sector, which is what we're concerned about at the moment, we have heat demand seasonality that should be considered. So if we were to electrify the entire heat demand, we would have huge peaks in winter and not so much supply of renewable energy during those times. Also, there's this peak in winter that I've talked about. So normally you would have electricity demand doubling or even increasing 3-4 times if we were to electrify the entire heat sector. And also there's the additional cost of reinforcing those grids to actually sustain that electrification. So electrification is not a silver bullet either. And with electrification and renewable energy, we're looking at energy that won't necessarily be affordable or necessarily be reliable. So we need solutions to close those gaps. Then we have energy efficiency, and we're looking to actually build more efficient homes. However, the challenge of that is that renovation rates and the build of new homes is rather difficult. I think renovation rates in Europe are below 3%, so more than half of the buildings that are standing today will be there in 2050. Which makes demand-side efficiency necessary, but not the only solution in terms of efficiency. And so we're left with supply-side efficiency, which brings us back to fuel cell micro-CHP. These are very efficient systems that can actually provide that sustainability. Then we have decentralized energy as well, and you have benefits of producing energy where and when you need it. So that's one of the solutions that we're thinking about when talking about the future energy system. And bringing everything together is integrated energy. So this whole concept of sectoral integration, integrating energy systems by linking electricity, heat, and gas networks. That's also something that will deliver some sort of solution to address some of these challenges. So the answer is actually that there's no single solutions that will deliver on all those challenges of the future energy system. So if we want a decarbonized energy system by 2050, we will need a mix of different solutions, optimizing between all of them and bringing them together. So this is just an example of how we see integrated energy systems. You can see here that you can make use of the gas grids, you can make use of the electricity grids, and also of heat systems and heat networks to actually bring together synergies and improve energy efficiency of the whole energy system, integrate more renewable energy, and at the same time bring the costs down for the entire energy system. And the benefit of cogeneration in all sizes, so from large scale to also fuel cell micro-cogeneration, is that it actually provides the biggest amount of links between these energy systems. So it links gas grids. It actually can use renewable gas in a very efficient way, and then it can produce efficient electricity and also efficient heat when consumers need it. So this dispatchability and this reliability of these systems are definitely a benefit. At the building level, fuel cell micro-CHP are definitely a solution that will play a role in the future energy system. So you can see here how different mixes of fuel cell micro-CHP plus PV plus batteries plus heat pumps, maybe not necessarily in the same building, but in the same district, they can work together and ensure that system reliability. When heat pumps demand is creating those peaks during winter, a fuel cell micro-CHP can provide low carbon and also efficient electricity to feed those heat pumps. Same way, if you have an oversupply of solar electricity, that solar electricity can be stored as renewable gas or hydrogen and then used very efficiently in a fuel cell micro-CHP. So there's definitely complementarities and synergies between distributed energy solutions. So why fuel cell micro-CHP? There are key benefits to this technology, as I hope I will have shown in this presentation. It empowers consumers, it supports the European energy transition, it provides greater flexibility because these are they provide dispatchable electricity and heat when and where it is needed. It's not intermittent, and it fosters innovation and high-value jobs. And this is an important point because, as I mentioned in the beginning, there's the key manufacturers that are investing in this technology and committed to this technology. So it certainly provides job opportunities, and it creates innovation in Europe. So further benefits of the technology: it actually delivers primary energy savings, it is reliable, it is modular. Being very, very small, you can actually install several units in an SME. You can install a unit in a small family house, so it's very flexible for that point of view. It provides distributed energy and power at low voltage level. And then when it comes to the status of the technology in the market, you see that new technologies, this is a state-of-the-art technology that has just entered the markets in Europe. There is a certain pathway for these new technologies. So in order to bring costs down, you need to scale up production and you need to actually sell quite a lot of units for that cost reduction to actually take place. So we consider fuel cell micro-CHP at early market introduction at the moment. As you can see here, in Europe we've had several projects that have tested the product. So Calux and the Ennefield projects in Germany and Europe respectively have tested the units and shown that these are reliable units. What we're doing now with PACE and what's happening in Germany with the KfW 433 projects is that we're trying to bring the product into the market and launch it, put it on a path to mass commercialization. And so that's the second step where we're at now. But what's also happening is that manufacturers are testing and developing new business models to bring the product to consumers and basically avoid the high upfront costs that these products will have for the coming few years. So new business models, for instance, providing energy as a service, and not making the consumer buy the product or own the product. And what we're also looking at the moment is low-cost finance. So we're in discussion with the European Investment Bank to actually have manufacturers access or have manufacturers access to low-cost finance to actually accompany those new business models and push for, again, product cost reductions. And so where we are now in terms of numbers, so we've seen sales rapidly increase. About 2 years ago, there were no more than 2,000-3,000 units sold across Europe. But we're now close to the 10,000 units mark. So with the PACE project, with the KfW project in Germany, as well as other projects happening and independent sales happening across Europe, we're close to 10,000 units being sold to date in Europe. And this will actually increase quite a lot. So in projections by the manufacturers and by some of these projects that are being carried out right now, we're expecting more than 60,000 units to be installed by 2022. What's also happening is that there's this industrial perspective to it, where manufacturers are committed to the product, are committed to developing ever better products, and are investing heavily into the fuel cell micro-CHP systems. So this is the range of technologies that is now available on the market. There was another announcement in ISH last week on a new Wiesmann system. Actually, the Fuel Cells and Hydrogen Joint Undertaking, in their annual surveys, they've reported that the stationary fuel cell sector, so fuel cell micro-CHP as well, are investing more than 100 million euro in these products in a year, so in 2018. And as I mentioned, there's new generation of units being installed and deployed into the market, which really shows that the industry has confidence into the product. So based on all of this evidence, we actually believe that fuel cell micro-cogeneration will play a key role towards this integrated, more efficient, more affordable energy system of the future. And as take-home messages, we think fuel cell micro-CHP are no regrets, future compatible, providing fastest carbon reduction pathways today and in the future. They already deliver a lot of emission reductions, between 30 and 50% reductions in CO2. They are fuel flexible, so it means they can run on natural gas today and hydrogen in the future. And they can actually contribute to the objectives of the EU in terms of energy and climate change. So we are very positive about the future of this technology. And we think it will develop further in the next few years. Thank you very much.
Thank you very much, Alexandra. Are there any questions from the audience regarding the project? No? Okay. So what do you think about the market in the future? Where is it heading at the moment? I mean, you showed us takeaways, but what else? What do you think?
Well, we could look at Japan for how the market developed in Japan. There, the industry and the government have worked together to actually launch the product into the market. So we've seen that to date there are about 250,000, close to 300,000 units installed in Japan. This was very much facilitated by the NFARM project, which provided decreasing subsidies as the costs went down. And I think this can happen in Europe as well. Of course, the European markets are different. So consumers are also different between Germany, Belgium, the Netherlands, the UK. So it will be a bit more difficult to develop those markets independently, but this is what we're trying to do with the PACE project, So we're basically seeing quite a lot of momentum growing. First of all, in Germany, that's really the leading market, but also in other markets as well. So, for instance, over the past 2 years, more than 500 units were installed in Belgium. So that's quite a huge momentum taking place.
Thank you very much. If you have further questions, they are at booth B59 or around after the presentation. Thank you very much again, Alexandra.